For this video, we're going to look at some sample problems from the 8-4 practice, and I have gone over some of these in class during the class meeting. Let's look at this angle of elevation depression, like 1 through 8. If we look, say, at the even ones, they want us to talk about angle 2. Angle 2 here is an angle of elevation as the boat is looking up towards the birds. So from the horizontal, it's an angle of elevation. Angle 4, from the point of view of the submarine, is also an angle of elevation because the submarine is looking from the horizontal up at the boat, so that's also an angle of elevation. Let's look at angle 6. Angle 6 from the observer on the hill is an angle of elevation as he's looking up to the plane from the horizontal. And let's look at 8. Here's horizontal from the boat at this water level. An observer on the boat is looking up at angle 8 at the observer. So those are all angles of elevation. Angles of depression are down from the horizontal, so birds looking down at the boat would be an angle of depression, and so on. Let's look at some of these other problems on this page. Let's look at number 11. Number 11, you've got a crane lifting a weight, and there's a shortcut here. Like they're telling us that this is a 45-degree angle. So actually what we have here is a 45, 45, 90, which gives us a special triangle way of solving this. But let's say we don't see that, and we just look at the active sides that are involved. This is the hypotenuse, so what we have is an opposite over adjacent situation with a 45-degree reference angle. So we're going to say that tan 45 is equal to opposite, which is 60 over x. Multiply both sides by x, divide by tan 45. This is, you swap these places here. X is equal to 60 divided by tan 45. If I do that on the calculator, we do 60 divided by 45 tangent. The tangent of 45 is 1. 60 divided by 1 is going to give me 60. So x is equal to 60. And the units are in terms of feet. Okay. Now, an easier way to do this problem would have been to recognize that if this is a 45-degree right triangle, we've got a 45, 45, 90 triangle, which gives us a 1, 1, radical 2 set of side lengths. It's isosceles. If this is a 60, this must be a 60. So we could have jumped straight to x being a 60 without having to do any work on that. Let's look at number 12. Now they're giving us diagrams for these. If they don't give you a diagram, you have to provide your own. You've got somebody on the boat is looking up at a 25-degree angle of elevation to the plane. They want us to see how high the plane is, knowing that the boat is 75 yards from the plane's position. So this is another tangent problem. Here's the hypotenuse. We have an opposite over adjacent. This is going to be tangent 25 is equal to x over 75, and the units are in terms of yards. Multiply both sides by 75. 75 tan 25 is going to be the height of the plane. So let's see what we get here. We do 75 times tangent of 25 equals 34.97. Up here it wants us to round to the nearest tenth of a unit, so 34.97 actually rounds off to 35.0. So x is 35.0 yards, or 35 yards. One other one, let's do number 14. So they don't give us a diagram for number 14. We have to provide our own. You've got an eagle perched 40 feet up in a tree, and he's looking down at a 35-degree angle of depression, and he spots an animal on the ground, and they want to know how far is the vole from the eagle to the nearest tenth of a foot. So from the eagle, I'm taking it that they want us to figure out what this length is of this hypotenuse of this triangle. If the eagle is here and the vole is there, they want us to figure out how far is the eagle from the vole. Let's see what else we got. We got the 40 foot there. We got the W. This 35-degree angle of depression correlates with a 35-degree angle of elevation by alternate interior angles. And with this as our 35 reference angle, we have an opposite over hypotenuse. So this is set up as a sine problem. Sine 35 is equal to opposite, which is 40, over W, which is the length of the hypotenuse. Variable in the bottom, switch places. W is going to be 40 divided by sine 35. And the units are going to be in terms of rounded to the nearest tenth of a foot. So let's bring the calculator over, and we want to do 40 divided by sine of 35. Oh, hit tangent. So we want to do 40 divided by sine of 35 equals 69.73. Rounded to the nearest tenth of a foot, it's 69.7 feet. So the eagle is 69.7 feet away from the vole. Let's look at the other side. Maybe there's a couple problems over here we can look at. Let's see. 15 looks like a good problem. You're standing 40 feet from a tree. Your eyes are 5 feet above the ground, and you're looking at the top of the tree at a 47-degree angle of elevation, and we need to figure out how tall the tree is. So we need to draw a diagram to represent the information here. Okay, so this represents the height of the tree. You're 5 feet above the ground, and you're measuring to the top of the tree at a 47-degree angle of elevation, and you're 40 feet from the tree. So at the end, we're going to have to add 5 feet on to compensate for us starting out 5 feet above the ground when we measure the tree. So we're actually going to use the triangle and just find this part of the tree. We'll call this Y, and then we're going to have to add 5 to it. So with this triangle, what we have is here's the hypotenuse. We have an opposite with an adjacent of 40. That's going to cause us to have to use tangent, and we're going to write tan 47 is equal to Y over 40, which is opposite over adjacent, or 40 tan 47 is Y. Now 40 tan 47, 40 times 47 tangent equals 42.89. The answer needs to be rounded to the nearest foot, so we could call this 43 feet. Y is 43. Now, so that this distance here is 43 feet, but the observer is 5 feet off the ground as they do the measurement. So we need to add that on to 43, and the tree is actually 48 feet tall. let's see. Let's look at number 18. Move this up. Okay, so somebody is, they're in a plane, they're looking down at a 22-degree angle at a building on the ground, and for some reason they know that that building is 12,000 feet away from the plane, and we need to figure out how high the plane is. So with this triangle as it's given, we have an opposite. Okay, here's hypotenuse. We have an opposite over an adjacent, so it's going to be a tangent problem. The angle is 22. So tan 22 equals opposite, which is x over 12,000, or 12,000 tan 22 is going to be x. And they're still wanting us to round to the nearest tenth of a unit. So we do 12,000 times tangent of 22 equals 4848.3. So 4,848 feet, 0.3 feet, because they want this to the nearest tenth. So the plane is not quite a mile high. It's like 100 feet less than being a mile high. Well, like 400 feet less than being a mile high, something like that, 450 or so. Let's see. Let's talk briefly about number 29. I did this in the class meeting, but it's important to notice as you're reading the problem that there's a difference in units. They're talking about the altitude of the plane in terms of feet, but they're talking about the building as being 50 miles away. So you have to have unit consistency. Everything needs to be in terms of feet when you deal with your numbers, which would be 5,280 times 50, and turn that into feet. Or everything needs to be in terms of miles, which would be divide 10,000 by 5,280 to get like 1 point something for the number of miles. And let's see, average angle at which it must descend. So let's represent this. So here's the plane. They're 10,000 feet up. They're needing to descend to a building at an airport that is 50 miles away. So 50 times 5,280 is going to give us feet, and they're 10,000 feet up, and they're wanting to know what the angle of descent is. What is the angle from the horizontal that the plane needs to head down towards the airport at? So in other words, they're asking us for this angle of elevation at the airport. You can call this angle A. So what we have here is a tangent problem. 10,000 is opposite, and 50 times 5280 is the adjacent, and this is going to be a tan minus 1. A is going to be tan minus 1 of whatever 10,000 divided by 50 times 5280 is. So in the calculator we need to do those numbers and then do tan minus 1 of that. And I'm not going to finish the problem, but basically that's how we need to set the problem up. And that's, let me talk here about these on the bottom. We didn't have a chance to talk about these today. Let's talk about, say, number 24 here. So here they're telling us that the angle of elevation is given in terms of 6x plus 3, and an angle of depression is given in terms of 3 times the quantity x plus 6. Since an angle of depression is equal to an angle of elevation, we actually set these two algebraic expressions equal to each other and solve for x. And then plug the x in, and that's going to give us the measure of the angle. And these two angles are going to be congruent by alternate interior angles. So for, say, 24, I'm going to say 6x plus 3 equals 3 times x plus 6. Distribute the 3, 3x plus 18 is equal to 6x plus 3. Get all the x's together on one side of the equal, subtract 3x from both sides. 3x plus 3 is equal to 18. Subtract 3 from both sides. 3x's is equal to 15, or x is equal to 5. So we found out that x was equal to 5, but we need to figure out what the angle is that goes with that. So plug 5 into one of these. 6 times 5 plus 3 gives me 33 degrees. So for number 24, those angles are 33 degrees. Okay, that's all we have time for on this one. If you have any questions, let me know.